So moving on, we've got another situation where we've got another substituent again, and you want to decide what your functional group is so that it takes priority. And no matter where the rest of the substituents are, those are the numbers they're going to get. But you get to put them in alphabetical order. So I'm going to start from left to right. 1, 2, 3. Well, that wasn't very long. Or I can go from right to left. 1, 2, and 3. So the yellow puts the hydroxyl group on the first carbon. And so we're going to number from left to right, which means that the chlorine, or our chloro group, is stuck on the third carbon. So this is 3 chloro. Now, you don't have to put the 1 in. If you want to, you can. It's not totally wrong, but we usually don't. This can just be propanol. I guess it wouldn't be super terrible to go ahead and do that because you could have had your hydroxyl group on the second carbon. Okay, so what about the next one? So we're going to number from left to right. So there's 1, 2, 3, 4, or I can number from right to left. 1, 2, 3, 4. So here is where in class I would say, which way do you guys want to go? And you would say, we're going to go from right to left because the hydroxyl group is put on the second carbon instead of the third carbon if we go from right to left, which means then that the bromo group is stuck on the fourth carbon. And our hydroxyl group is on the second. And this is butanol. Okay. So what if you get the same number for your functional group if you number it in both directions? So what do I mean by that? Well, let's number this first one. So if I go from left to right, 1, 2, 3, 4, and 5, or I can go from right to left, 1, 2, 3, 4, and 5. So I got a 3 no matter what. What are you going to do? Well, since I got a 3 in both directions and I have another substituent, I'm going to give that substituent the lowest possible number. So if I take the green path, the chloro group ends up on the fourth carbon. If I take the yellow path, the chloro group ends up on the second carbon. So I'm going to go ahead and take the yellow path, and that puts 2, sorry, I was looking at the hydroxyl group, 2 chloro, and then 3 pentanol. So for the next one, we have a ring, right? So this thing can be numbered a couple of different ways because your functionality is the hydroxyl group, and so the alcohol is going to take priority. The methyl group is just a substituent. So I could go in this direction, 1, 2, 3, 4, 5, and 6. Or I can go in the other direction and say 1, 2, 3, 4, 5, and 6. So because the hydroxyl group is on the first carbon, this is a cyclic compound, so we don't even have to tell anybody that we're on the first carbon because this is going to be a cyclohexanol of sorts, but it's got something hanging off of it, something else. We have a methyl group. 3 is smaller than 5, so we can write 3-methyl and then just cyclohexanol. because it's a cyclic compound and the priority is going to be the alcohol. So it's implied that it's sort of hanging off of the first carbon. So you get to number that only in 2 directions for this particular molecule. And we picked 3-methyl instead of 5-methyl because 3 is smaller than 5. What if you have more than one other substituent on the molecule? So I'm going to find my longest continuous chain of carbons that contains my functional group as usual. So 1, 2, 3, 4, 5, 6, 7. I didn't go up through that ethyl group, right? Because number 1, my longest continuous chain has 7 carbons, and that would only be 6. Plus, I wanted to include the hydroxyl group. But I also want to make sure that my functionality gets the lowest possible number. So I'm going to go this way as well. 1, 2, 3, 4, 5, 6, and 7. So when we look at this, the yellow path puts the hydroxyl group on the 6th carbon, but the green path puts it on the 2nd carbon. So we're going to take the green path, which means that we have an ethyl group on the 4th carbon, and we have a bromo group on the 6th carbon. So because we have 2 totally different substituents, we're going to cite them alphabetically. And bromo comes before ethyl, even though 6 is bigger than 4. So it's 6 bromo. And then dash, because we use these to separate our numbers from our words. So it'll be 4 ethyl, 2 heptanol. So this is a heptane derivative, right? And so we drop the E, we add OL because it's an alcohol. This tells us that our hydroxyl group is on the 2nd carbon, that the parent compound has 7 carbons. The OL tells us that it's an alcohol. 4-ethyl says that on the 4th carbon, you should find an ethyl group, and on the 6th carbon, you should find a bromo group. So for this particular class, this is about as heavy as it's going to get with the nomenclature of alcohols. But what about their sulfur analogs? So with thiols, we have a little bit different for our nomenclature, a little bit different nomenclature. Thiols are going to tell us that we have the SH instead of the OH group hanging off of our parent hydrocarbon. And if we have to use that particular functionality as a substituent, like what if, for example, it's hanging off of another molecule with a functional group that actually takes priority over it? Like what if you had that group hanging off of an alcohol? So we can actually use the word mercapto instead of thiol in that nomenclature, and that's going to be when the sulfur group is actually a substituent. And the reason they're called mercapto groups, these guys used to be called mercaptans because they have a tendency to form complexes with heavy metals like arsenic or mercury. So mercaptan means it captures mercury. So let's name a few of these. What you're going to do is you're basically just going to add the word thiol to the end of the parent hydrocarbon. This is not complicated. So for example, that first one there, you see there's an ethane derivative, right? So this is ethane. And what's different about this ethane? It is a thiol. The end. That's they're not too bad. So what about the next one? So that's 3 carbons. This is propane. And then thiol. By the way, these particular molecules smell horrible. They smell horrible. Some of them are like rotten eggs, like you'd expect probably from some sulfur compound. Some of them smell like burning rubber. Nearly all of them will give you some sort of weird headache. Some of them smell like, well, actually, there's a thiol compound that they add to natural gas so that you can detect an odor. If there's a gas leak, it's not actually part of natural gas. It's added to it so that you know if you got an issue. What about this next molecule? So just like with the alcohols, we're going to use the word or the prefix di to let someone know that there's two. And so I've got ethane, di, thiol. And I suppose you could have the thiol groups hanging off of the same carbon. So you could say 1, 2 to let someone know that they're on different carbons.